Trigonometry of right angles. First thing I'd like to talk about is the following. We'll call that the line or sight. Let's actually make it horizontal. Perfect. It's the line or sight or the horizontal. If you observe something up here, that's called an angle. This angle is called angle of elevation. Why? Because from the horizontal, it went up. If you're looking down there, maybe on the ground or even below the ground, that angle is, this angle here is called angle of depression. If you look up, it's elevation. If you look down, we call it the angle of depression. Okay. Now, so people always say, why do I need to learn trigonometry? Oh, here's a great reason to be able to use trigonometry. Suppose there's this very tall building, your house. It's maybe 10 feet tall. Now, you want to buy a ladder and here's the ground. You want to buy a ladder so you can do some work on the roof, okay? Now, you have a couple of choices. You can go to the ladder store and you could randomly pick out a ladder, and maybe it'll be tall enough. Maybe it'll be too tall. And maybe you spend more money than you need it to. And who wants to spend more than they need to? So, either you can just live with this ladder that's too tall and that you spend extra money on, or you have to go back to the store and buy a shorter ladder, and possibly that shorter ladder or the first ladder you bought was too short, so now you have to go back and buy a larger one. Or you can do the following. You could measure on the ground 100 feet. I'd rather measure something on the ground. Oh yeah, the other option is you can go on the roof and drop a rope to the ground and measure the length of that rope. That's another thing. Now my question would be how are you getting up on the roof if you don't have a ladder? So, maybe you borrow your neighbor's ladder and you go up to the roof and you drop the rope. Hopefully your rope is long enough, and then you measure the rope. Or on the ground, nice and relaxed, you measure off 100 feet. And then you take your protractor and you aim a beam of light, a flashlight, right up to the top. And you say, oh, protractor says 30 degrees. You can find the height of this building. Let's call it h. You know that the tangent of 30 degrees is the opposite divided by the adjacent, which is 100 feet. That means 100 times tangent of 30 degrees is h. And you can go use your calculator to do this. Okay, everything at your leisure. You don't have to go to the store and randomly buy ladders and return them. You don't have to borrow your neighbor's ladder and drop a rope. Maybe you have to buy the rope first. It's a lot easier to use trigonometry. Now, if you don't know how to calculate this, you can always use your calculator. But basically, we know this is a right angle. This is 30. So, if this is 30, that must be 60. And here's a right angle. Their sides are always in this ratio. 1, 2, square root of 3. That is, this here may be 10 times square root of 3. Well, then this will be 10 and this will be 20. They'll all be multiplied by 10. And if you divide this by that, the tens will cancel and you'll get 1 over square root of 3. Just like if you divided those two. So the tangent of 30 degrees is opposite over adjacent. It's 100 times 1 over square root of 3. That is 100 over square root of 3. That is your h. Now I guess you really do need a calculator. But I'd rather do that than... So all I really did was measure off 100 feet and then put my compass, or is it protractor? Forget what draws a circle. But the one that measures an angle, I just put a light bulb here and I aim it at the top of the building, and then I read this mark right here, which is 30 degrees. And I'm done. I go back to my house and I figure things out. Same problem over here. Here is some building, maybe it's your house, and you want to know how tall it is. And maybe already you measured out 50 feet. Many years ago, you planted a tree right here, and you didn't want the tree close to your house, because when you put a tree here, the roots grow and grow and grow, and all of a sudden, the roots are in your house. Okay, you don't want a tree growing in your house. Okay, so you already know it's 50 feet, because many years ago, you measured it. Okay, so once again, you aim, put a light source right here. You aim it up to the top of the house, and you read that angle, and it says 75 degrees. And you want to know the height of your house. So, tangent of 75 degrees is equal to the opposite over the adjacent. It's h over 50. But this times that always equals the top. So 50 times tangent of 75 degrees is h. Go and get your calculator. Calculate 50 times the tangent of 75 degrees, and you have the height. And all you did is you put your angle measurement tool here. You put a light source right there. You aimed it up to the top of the building, and it said 75 degrees. And then you did this, which gave you that, and now you have a way of getting h. Just multiply tangent of 75 degrees by 50 and be done. It's a lot easier putting your tool here and measuring 75 degrees than it is to buy various ladders and, whatever number this is, you want a ladder longer than that, because you don't want to buy a ladder that's exactly that long, because then you can only put it up against the building. The ladder has to be more like that. So you just want to get something bigger than this. Now, suppose the following. Here's a nice problem. This is the ground. You have one building, and you have another building. And you live right there on the third floor. And all you know is that the distance between the two buildings is 120 feet. And you want to find the height of this building. How tall is this building? That's what you want to know. So here is your horizontal. And once again, you play games measuring the angle. You find that angle. It is T1. You find that angle. No reason why it should be the same, unless you're in the center of that building. That is, you're at the same height as the center. Okay, so we'll call this, I don't know, H1, and we'll call this H2. Now, you know that this length is 120. Even in the lower triangle, you know this, here's a right angle, here's a right angle. In triangle 1, we can find H1. We know that the tangent of T1 is opposite over hypotenuse. It's H1 over 120. That means H1 is 120 tangent of angle T1. Now, this height right here, that can be figured out by the tangent of T2. Tangent of T2 is opposite H2 over adjacent, which is 120. So 120 times that equals H2. H2 is 120 times the tangent of T2. Now, the total height of the building, I hope is clear. It's H1 plus H2. So let H be the height of the building. So H is H1 plus H2, but H1 is 120 times the tangent of this angle plus H2, which is 120 the tangent of that angle. I mean, if you like, you can factor out the 120, and it's the tangent of one angle plus the tangent of the other angle times 120. But we can find the height of this building if we are in that building and not even on the floor. We're not even on the ground floor. Okay, we do it in two halves. First, we find the height from the horizontal line from your window to the top, and then we find from the horizontal from your window down to the floor. And the sum of these two heights, I hope is kind of obvious, that the sum of these two heights is the height of the building. The blue plus the pink is the height of the building. Now, suppose we somewhat reverse the problem. Here's the ground. Here is one building. They tell you it's 100 feet tall. And here's another building. They tell you this building is 100 feet tall. Let's decide if we need all of this. And they want you to find the distance between the two buildings, but they tell you that this angle is 60 degrees. Now, from the base of this building to the height of that building doesn't have anything to do with the height of the left building. It can be taller, it could have been shorter. All that matters is that that left building starts right there, and the right building starts here and ends up here. Doesn't matter how tall this left building is. In fact, there doesn't even have to be a building here. There doesn't have to be a building here. The bottom line is you decide to stand right here and measure the distance by figuring out this angle and knowing this building is 100 feet tall. So now you know that the tangent of 60 degrees, tangent of this angle is the opposite divided by the adjacent, which is D. Now, a lot of teachers don't teach you this. I don't know why. 8 over 4 equals 2. Notice 4 times 2 is 8. Now, if you switch those two numbers, 8 over 2 equals 4, it's still going to be true because 2 times 4, 4 times 2 is equal to 8. Okay, 16 over 8 is equal to 2. If I switch those two values, I still get a correct answer because 8 times 2 has to be 16, and 2 times 8, that's the same as 8 times 2. You can always switch these. So if you ever have 16 over x is equal to 3 and your teacher says solve for 3, the problem should take no more than 3 seconds, and there it is. All I do is switch those two. If it was more friendly, less friendly was easy. We couldn't reduce 16 over 3. More friendly would be something like this. And you should know 16 divided by 8 is 2. But if you didn't, you get 16 over 2 is 8. And then you should reduce that. So either way you get 8. Either from knowing 16 over 8 is 2, or just knowing you can switch these two. The x is 16 over 2, you should reduce it. Okay, so having said all that, let's go and see why I mentioned it. Oh, because I want to switch these two. Because when I do, I have D equals. D is equal to 100 feet over the tangent is 60 degrees. You could then take your calculator and solve for D. Suppose you have this right triangle. This is right. This is X. This is 120 feet. And this is 100 feet. Now, this might be a more realistic question. Okay? You know the height of your house. It's 100 feet tall. I guess that's a pretty tall house, but work with it. And you have a 120-foot ladder. And you put one end of the ladder at the top of the house and the other end on the floor. In other words, if this is your house, and here's the ground. Oops, the ground was a little bit lower. Here is the ground. You're not putting the ladder like that. Okay? You're making the tip of this ladder be right here. The tip of the ladder is right at the height of your house. Okay? And maybe you want to do something and you want to do something right over here, and you want to make sure you want to plant their tree. And there's a rule of thumb that the tree has to be at least this number of feet away from the house. So this is pretty good. You know the height of your house. You know your ladder is exactly 100 feet tall. So now you can find X. Or I would ask Pythagoras for help with this. 100 squared. No, I apologize. X squared plus 100 squared is equal to 120 squared. 120 squared. That is, X squared is 120 squared minus 100 squared. Now you should remember that A squared minus B squared, you can add the things being squared, you can subtract the things being squared, and then multiply it. Well, when I add them, I get 220. When I subtract them, I get 20. Well, multiplying by 20 is similar to multiplying by 2, which you can almost do in your head. But don't forget to add that 0. So, now, that makes no sense because the hypotenuse is supposed to be the longer side. I have no idea what is going wrong here. This is excuse me. That's what X squared equals. So X will be the square root of this. Now, what I know about 4400 is it's a multiple of 100. 4400 is 100 times, well, let me write the 100 first. It's 100 times 44. It's 100 times 44. But 4 is 4 times 11. The reason I want the 100 and the 4 is I know the square root of them. I know the square root of 100. I know the square root of 4. I have no idea what the square root of 11 is. And it's between 3 and 4. So I get 20 square root of 11. Now, the square root of 11, as I just said, it's between the square root of 16 and the square root of 9. That is, it's between 3 and 4. If I multiply the middle by 20, I have to multiply those numbers by 20. That is, what I know for sure is this is between 60 and 80, which makes me happier because it's less than 120. This is 20 square root of 11, which is between 60 and 80. Now, if they say that you have to plant the tree at least 60 feet away from your house, you're perfect because it's more than 60. And it's less than 80. You don't care how much it's less than. You just want to make sure it's bigger than 60. Okay? But then again, you can get a better approximation using a calculator and then judge whether or not you're within their amount that they claim the trees should be at least away from your house. This is very serious stuff. It really makes your life easier. Okay. One next and last problem. Suppose you have an equilateral triangle. All three sides are 2. And you're asked to find the height of this equilateral triangle. And the height is going to be this distance. Now, since it's equilateral, this angle is 60 degrees, this angle is 60, and this big angle is 60. But this triangle is extremely symmetrical. That is, these are each going to be 30. Why, if it's so symmetrical, all angles the same, all lengths the same, why when you go straight down at a right angle, why might it become 20/40, which is 60? So 60, 60, and 20/40. Makes no sense. The only way it can be 20/40 is if it's not symmetrical. But this triangle is symmetrical. Okay, so we call this H. Let us look at the right triangle. We have this is H, this is H, this is 2, and we know that the whole base is 2. But since it's so symmetrical, this point cut the 2 into 2 equal parts, 1 and 1. This is 1. Okay, now Pythagoras comes along. H squared plus 1 squared, which is 1, is equal to 2 squared. Well, 3 plus 1 is 4. H squared is 3. So H is plus or minus the square root of 3. Well, it's meaningless for H to be negative because H is the height of a triangle. You ever hear of a triangle that has a negative length? So the height of that triangle is the square root of 3. So now you can find the area. The area is 1/2 times, say, the base, which is 2, times the height, which is square root of 3. Half of 2 is 1. 1 times square root of 3 is the square root of 3 square units. Okay, because maybe the base was 2 inches, the height was square root of 3 inches, and inch times inch is square inches. this completes this video entitled Trigonometry of Right Angles.